50,000 years ago, this planet had more than one kind of human on it. Not early humans in some vague evolutionary chart sense, actual separate species, living at the same time, sometimes in the same valleys. One of them stood a little over 3 feet tall as a full-grown adult. Another one we only know existed because of a single bone from a child's little finger. Today there's just us. We are the only human species left on Earth. Not because we were the strongest, not because we were the smartest, not even because we'd been here the longest. We hadn't. We're just the ones who are still here. Which leaves an uncomfortable question hanging in the air. What happened to everyone else? The honest answer isn't a single event. It's not a war we won or a disaster that spared us. It's slower than that and messier than that. So to actually understand it, we need to meet the species this happened to, starting with the one that outlasted almost everyone and still didn't make it. Homo erectus showed up in Africa roughly 2 million years ago, source 1, 2. Put that number next to something familiar. Every city humanity has ever built, every war, every language, all of it fits into the last few thousand years. Homo erectus was around for a span of time so long that the whole of recorded human history barely registers as a rounding error next to it. Their bodies were the first to really look like ours. Long legs, shorter arms, a frame built for covering distance on foot. They were the first human species known to leave Africa, spreading into environments their bodies had never evolved for, source 2. Their brains were smaller than ours, but far bigger than anything that came before, and their stone tools barely changed for hundreds of thousands of years. That sounds like stagnation. It's actually closer to the opposite. They'd built something that worked so well there was no pressure to reinvent it. But their final chapter tells a different story. The last confirmed population lived on the island of Java, and for years, scientists argued over exactly when they disappeared. Estimates swung from as recent as 27,000 years to as old as 500,000, source 1. A major redating effort, using more than 50 separate radiometric measurements, narrowed it down. Their last known fossils date to somewhere between 117,000 and 108,000 years ago. As their forested hunting grounds gave way to rainforests they weren't equipped to live in, source 1-2, a species that had survived for nearly 2 million years ran out of usable land before it ran out of time. Now, here's a species that got almost everything about its reputation wrong, the Neanderthals. For decades, the word Neanderthal was basically an insult. Dumb, hunched, brutish. That picture was never accurate, and the more evidence we dig up, the worse it looks for the people who invented the stereotype. Neanderthals were built like they were designed for punishment. Wide chests, thick bones, powerful arms, heavy brow ridges, wide noses built to warm, freezing air before it hit their lungs. Their brains, on average, were slightly larger than ours, source 4. They hunted large, dangerous animals at close range. Their skeletons show injury patterns that match modern rodeo riders. They controlled fire. They made composite tools. There's real evidence they buried their dead with care, source 4, 17. They held on to Europe and Western Asia for over 300,000 years. Then, around 45,000 years ago, Homo sapiens started moving into the same territory. For a stretch of time, current estimates put it at somewhere between roughly 2,000 and 6,000 years depending on the region. Both species lived in overlapping ranges, source 3:15. We know they didn't just coexist. DNA evidence proves they had children together, and that Neanderthal DNA is still in the genome of almost anyone today whose ancestry traces outside Africa, source 4. But shared territory meant shared competition for the same animals, the same land. And here's where it gets interesting. It might not have come down to intelligence or even direct conflict. Neanderthals are estimated to have lived in small bands of maybe 5 to 15 people. Sapiens groups could run up to 150, source 4. One recent study modeling this more rigorously found something striking. It wasn't climate alone, and it wasn't competition alone that explains the difference. It was how connected each species' social networks were. Homo sapiens groups were linked to each other in ways that let knowledge, resources, and people move when conditions turned bad. Neanderthal networks were more fragile, more regional, and when the climate got unpredictable, that fragility mattered more than raw survival skill. Source 1314. By around 40,000 years ago, Neanderthals disappear from the fossil record, not from one single catastrophe, from competition, shrinking, and increasingly isolated populations, and a changing world closing in from multiple directions at once. Source 3. Now the Denisovans, a species we can barely even prove existed, and yet one that's still inside millions of people alive today. This whole discovery starts with a single bone, a fragment of a child's finger, found in a cave in Siberia's Altai Mountains, small enough to sit in the palm of your hand. Source 5.6. When scientists pulled DNA from it, it didn't match Neanderthals. It didn't match us. It didn't match anything on record. It was something else entirely. A branch of the human family that had been sitting in the genetic shadows the whole time. Since then, the physical evidence has barely grown. A handful of teeth, a jawbone fragment found high on the Tibetan plateau, scattered pieces from caves in Russia, China, and Laos. That's essentially the entire fossil record of an entire species. Source 5. And yet their genetic footprint is enormous. Denisovan ancestry shows up across populations in Asia and Oceania, and in Melanesian groups today it can make up around 5% of the genome. Source 7. Here's the part that should stop you. Tibetans carry a gene called EPAS1, inherited from the Denisovans, that lets their bodies function at altitudes where most people's blood would start to fail them. Researchers found the gene's exact structure could only be explained by interbreeding with Denisovans thousands of generations ago. Source 8. A species we can barely find in the ground is still quietly keeping people alive on mountains today. As a living population, though, the Denisovans faded, likely sometime after around 30,000 years ago. Source 5. Wide range but probably thin numbers, and thin scattered populations rarely hold on once the ground shifts underneath them. And then there's the strangest chapter of all, a human species that when it was first found, most scientists refused to believe was real. In 2003, on the Indonesian island of Flores, researchers pulled a nearly complete skeleton out of a cave, an adult, fully grown, standing about a meter tall. Source 9. At first, a lot of scientists assumed it had to be a modern human with some kind of growth disorder. But the skull had the wrong shape for that, the teeth were fully developed, and eventually the evidence became impossible to argue with. This was its own species, Homo floresiensis. Source 9. They shared their island with Komodo dragons, giant storks, and dwarf elephants. Source 9. Islands do strange things to evolution. Big animals tend to shrink, small animals tend to grow, and isolation pushes bodies in directions you wouldn't see on a mainland. Homo floresiensis might be one of the clearest examples of that process in the entire human story. Here's where the story gets messier than it first looked. When the fossils were first dated, scientists thought this species survived until just 12,000 years ago, recent enough to have crossed paths with us fairly late. A more thorough re-excavation published in 2016 pushed that number back dramatically. The skeletal remains are now dated to somewhere between 60,000 and 100,000 years old, roughly 10,000 years before modern humans are known to have reached the region. Source 10. For a while, the leading theory was that our arrival ended them anyway. But newer archaeological work has found evidence pointing somewhere else entirely. A severe drought that hit the island independent of us. Source 11. It's a live scientific argument, not a settled one. Sometimes a small isolated population doesn't need us or a catastrophe. It just needs the world to get slightly harder for slightly too long. So why are we the only ones left standing? The easy answer is intelligence. it falls apart almost immediately. Neanderthals had brains larger than ours on average. Denisovans adapted to some of the most extreme environments on the planet. Homo erectus outlasted us by a factor of nearly 20. Homo floresiensis survived on a shrinking island for tens of thousands of years with a brain a fraction of our size. If this were purely about raw brain power, several of them should still be here. What actually seems to have mattered more is something harder to put on a highlight reel: connection. Homo sapiens didn't just live in groups. We built networks between groups. Tools, techniques, and survival knowledge move between communities in a way that doesn't show up at the same scale for the others. There's evidence early Homo sapiens ran long-distance exchange networks that could cushion a group against a bad season, a failed hunt, a collapsed food source. Resources and know-how could travel even when a single group couldn't. Source 17. When one community hit a crisis, what they knew didn't disappear with them because it had already spread somewhere else. Recent modeling backs this up from a different angle. For Neanderthals specifically, it wasn't climate change or head-to-head competition alone that explains their disappearance. It was that their social networks were smaller and more isolated, so the same climate swings hit them much harder. Source 13-14. But even that's not the whole story. Some of this really was luck, being in the right region with the right numbers at the right moment. It's worth remembering that our own species nearly didn't make it either. Genetic evidence points to a period, hundreds of thousands of years ago, where the entire global population of our lineage may have hovered around 1,300 people for over 100,000 years. Source 12. We weren't destined to be the last one standing, we just happened to be. The species you just heard about weren't rough drafts of us. They weren't stepping stones on some ladder leading up to Homo sapiens. Homo erectus survived for close to 2 million years and still ran out of road. Neanderthals endured ice age after ice age and still disappeared. The Denisovans left behind almost nothing physical, and yet part of them is still in the blood of people alive on this planet right now. Each of them was its own answer to the same question: how do you survive as a human on this earth? For almost all of human history, we were one branch on a much bigger tree. Now we're the only one left. And if there's one thing worth sitting with, it's this: being the last one standing was never a guarantee. It still isn't.